Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. In this video lecture series, we are discussing the subject called Programming for Problem Solving. And today we are going to start a new topic called the union in C. Now, union is also a user-defined data type. See, in the last lecture, we have started discussing about the user-defined data types, and the first one that we have studied are the structures. The structures are very powerful user-defined data types. It provides you the flexibility that cannot be provided by the conventional type data types or the non-user defined data types. And today we are going to finish the user-defined data types with uh, discussing the last one, the last topic of this unit, probably union. So let's head back to the notes and start exploring the union. Okay, so like structures, union in C language is a user-defined data type that is used to hold different types of elements. Like in the last class, we have seen that a structure can hold. Structure is also a user-defined data type and it can hold different types of data in a single encapsulation. Encapsulation means a single boundary. Okay, let's say we have defined a structure called S, and in that we have defined two members, one of type integer and one of type float. Then you can see that that particular user-defined data type that is being called by the name S holds two different types of data. One is of type integer and other one is of type float. Now union also holds the same properties as of structures. That is, like in structures, in union also you can define different data types in a single encapsulation, in a single let's say block, and you can call it by any name you want. But there is a basic difference in the union and structures. We'll discuss that in a few moments. But first, let's head to the main top. The first thing I want to discuss is how do we declare a union. Now, as you can see inside the notes, I have contrasted the declaration of structures and union side by side. In the first, you can see the declaration of the structure. We have seen that already in the last lecture. And there you can see the declaration of the union. The declaration of union will also uh, will be also, let's say, subside outside of the main function and before the beginning of the main function, like structures. And the keyword union will be used to define a union body. Okay, now there, for example, in this particular example, I have defined a union with keyword union and then name of the union, that is EMP. Then the curly braces will start, and inside this curly brace I will define the different members of the union. Like in structures, we have defined the different members of the structure. I will define different members of the union EMP. The first member of EMP is a variable X of type character. Next is a variable Y of type integer, and last member is a variable Z of type float. Okay, so this particular union, which has been named as EMP, has three members. First member is an character type variable X, next is an integer type variable Y, and last one is a float type variable called Z. Now we can also declare let's for the moment forget about what I have written here with this red pens, and let's head back to the initialization of the union. Now we have just declared the structure, or not the structure. I will not use structure word, otherwise you will get confused. But I will say I have only declared the union, the body of the union here. In actuality, Like in structures, you can define the variables of type EMP with two options. The first option is inside the main function that we have already, like in the structures, we have already seen that inside. Let me go back to the sense. Suppose this is your main function. Don't mind the caps. It's just a property of the word I'm using. And let's say I have defined an union called EMP. So how do I define the variables of type of union type EMP? So what I have to do is, like in structures, I have to write the keyword union, then name of the union that we have defined already above the main function, like we have seen in the notes. Let's take that example also. Same example called EMP, and first variable E1 and second variable E2. So by this example, I am trying to convey you that we have defined a type of union which has been named as EMP. Now, this is my user defined data type EMP, which is actually a union. Now I have declared two variables of type EMP. First one is E1, next one is E2. Okay, so E1 and E2 basically signifies, so E1 and E2 basically signifies two user defined data types, and the user defined data type that E1 and E2 signifies is called by the name EMP, and EMP is actually a union. Okay, I think I am pretty clear now. Now this particular line is somewhat similar to structures. We have also already seen how we can define the variables of types structure inside the main function. Instead of union, we have to use just the keyword struct, and everything else will be same. And like in structures, the body of the union will be defined above the main function. That is, there I have to define union there above the main function. We'll in a while we'll see how we can do that inside the IDE. We'll also try to realize an working example in the IDE. But for now, you can have a feel what I'm trying to say. So let's get back to the notes. Now, the basic difference between union and structure is the memory management. Everything else is same. Let's come back to the line that we have skipped earlier. But it does not occupy sum of all member size. It occupies the memory of largest member only. Okay, so that is the basic difference between structure and union. Structure, actually, when you initialize a structure, the compiler will reserve the memory equal to the total size of all the members in the structure. So what I'm trying to say is, let us define this particular structure. Now this particular structure contains a variable of type char, and as you know, the size of the compiler will reserve 1 byte of size of memory for this particular variable, and an integer type, the compiler will reserve 2 bytes of memory, and for float it will reserve 4 bytes of memory. So total continuous memory locations compiler is going to reserve for the struct EMP will be 1 plus 2 3 and plus 4 7. Total 7 continuous memory locations, 7 continuous bytes of memory location will be stored, or not stored, but will be reserved by the compiler for the structure called EMP. Now for the union, the case is not the same. Although I have defined this union exactly as this structure with names and character variables same, but the main difference is, for union, compiler will reserve the memory equal to the largest member of the union structure. Now the largest member of this union is this float variable, and as you know, the float variable, for every float variable, compiler will reserve 4 bytes of memory location, So the total memory location used by the union will be 4 bytes, as you can see in this line. So the size of union EMP, whose variable we have defined is E1. So you can say the size of E1 is actually 4 bytes and not the 7 bytes, because the size of the union E1 will depend or will be equal to the size allocated by the compiler the largest for the largest member of the union E1, and the largest member of the union EMP or E1 is this variable Z, which is of type float. And by largest I mean to say which variable occupies the largest size in memory, by the compiler, or which member of the union actually the compiler will reserve the most number of memory locations. So in this example, compiler will actually reserve the maximum number of size, that is equal to 4 bytes, for the float type variable Z. And as the maximum size is of Z, which is of type float and which is equal to 4, so this 4 will become the total size of the union EMP, whose variable we have defined as, or whose let's say variable, okay, whose variable even we have instantiated. And one more point is, the memory will be reserved only and only when we declare a variable of type EMP. Just declaring the structure or the body of the union EMP will not reserve anything for it. When we declare a particular variable of type EMP, only and only then compiler will reserve some memory location for it. Okay, so I think it's pretty clear now what is the main difference between structures and unions. Uh, so the main advantage will again then be that it occupies less memory because it occupies the memory of largest member only. And the disadvantage is, because of this, we cannot store all the members at once. We cannot initialize, okay, we can initialize all the members at once, but we cannot access all the members of union at once. That means at any point of time, any one of 3 members of the union EMP called X, Y, and Z can be accessed. Other 2 will be wiped out because we have the maximum size of memory for the largest variable only. So only one variable will be stored at one time. Okay, so what I'm trying to say is, I've prepared some slide for you. So you can see here that we have, okay, this is the basic difference. What I'm trying to say here is, for this particular structure, we have a character array, a character variable called X, which is of size 1 byte, and a float, which is of size 4 bytes. So total, after the initial declaration of this variable E, which is of type EMP, which is a structure actually, the total memory locations, continuous memory locations, the compiler will reserve will be 5. That is, different memory locations for X and different memory location for 5, and both of them will combinedly be the memory locations reserved by the compiler for E. But not in the case of union. In the case of union, the maximum of these two, that is X and Y, will become the total memory location of the union E. In this case, float will have 4 memory locations and character will have 1 memory location or 1 byte size. So the total memory assigned by the compiler for the union, for the data variable E of type EMP, will be 4 only, 4 bytes only. Okay, I think you got the point. What I'm trying to say is, so anyone of X and Y, which actually compiler will allocate the maximum size, will become the actual size of the union variable E. So going to the next slide. Now this is the basic difference between structures and unions. I will read it out, and if anything is different, then I will try to explain it. Although I have almost explained what it meant. So the first difference between both of them is how you will define a structure and union. The structure is defined by the keyword struct, and union is defined by the keyword union. The size is the main issue. That's why unions are created instead of structures. When a variable is associated with a structure, the compiler allocates the memory of each member. The size of the structure is greater than or equal to sum of size of its members. Okay, we have seen in the example just a while ago. While in a variable, when a variable is associated with a union, the compiler allocates the memory by considering the size of the largest memory. So size of union is equal to size of largest member. That is what we have done here. The largest member of this particular union is float type variable y. It has a memory size of 4 bytes. So 4 byte will become the total memory of union variable e. The next one is each member within a structure is assigned unique storage area location, but in the union, the memory allocated is shared by the individual members of union. So what we are trying to say here is whatever be assigned to this member X will be assigned will go to its respective exclusive memory location, and whatever be assigned to this variable member Y will be stored in the exclusive memory locations, that is this particular location. While in case of union, the total memory location is shared by X and Y both. So either the value assigned to X can be stored here or the value assigned to Y can be stored here. So that is why we can access only one of them at a time and not both of them. So that is the limitation of unions. Next, value altering. The altering the value of member will not affect other members of the structure. Altering the value of any of the members in the union will alter other members because, again, as I've told you, the memory location is being shared by all the members. So any changes to the data stored in the memory location can affect other members' values also, because size of the value depends on what you have inputted or what will be the maximum or minimum value that you are using to try to store there. Now, accessing members, we have already discussed that for structures, individual members can be accessed at a time, but for unions, only one member can be accessed at a time. And last but not the least, initialization of the members. Several members of a structure can initialized at once. We have already seen that in the last lecture, but only the first member of union can be initialized, or you can say the last member. And you can correct that, only the last member of the union can be initialized, although you can struck off this completely, this particular let's say difference, because you can initialize all of them, but only one of them will be stored in the memory location. There is no restriction on initializing each individual member of a union. All of them will be initialized. Compiler will not throw any let's say error, but in the end you can access only one of them because the memory is shared by all of them. So you can strike off this last one if you want. If you don't get it, I will not recommend writing this one for exam. I think 5 of the differences are more than enough. So let's get back to the notes. So we have seen all this. What is the difference between unions and structures? What are the unions and how we can define it? Last but not the least, just a quick example how we can see the unions in action. So let's get back to the IDE. I will quickly write an example here. So hash include .h, and I will also call one more directory here using string include string.h. It just gives me power to use the string function, that is it. So nothing special about it. Now if I have to define a union here, we have to use the keyword union. and let's say name it EMP and start its body. So the first variable is, let's say, int age, and next will be float salary, and last one would be the name of let's say name, first name, and I want this to be of length, let's say max 30. Okay, and let me initialize one EMP right here, let's say E1. Okay, so let's go to the main function. So as you can see, the memory allocated for the data type EMP, which is actually a union, will be 30 bytes, because the maximum size of these three members is this name. Int age will have 2 bytes, float salary will have 4 bytes, and this char name, because single char exist or exist only in one single byte, I have reserved 30 of them, so total memory will be 30 bytes. This E1 will have a total memory reserved for it by the compiler equal to 30 bytes. Okay, so let's quickly try to initialize each member. So again, like the struct, we can initialize each member individually by using the dot operator. So all I have to do is name of the variable, that is E1 dot, first one is age, let's say equal to 25, and then E1 dot salary will be equal to, let's say, 25,000 dot 50, because I can do that, I have declared it as float. And last, let's name it star cpy. This is a function called string copy. So E1 dot name, and I will write, let's say, Mohan. Okay, so what I have done here is I have called a function strcopy, that is string copy, which is defined in this particular directory. Nothing special. Whatever be the string I will pass here will be copied to this particular string here. Nothing special. Okay, just basic string function. Now all I have to do is write 3 printf functions, and for int I have to write %t, and again to access a member is E1 dot age, and let's copy it, let's not waste time. Okay, for float I have to use f, and also I will want them to be printed in new lines, not on the same line. Sorry. Okay, and not age, salary, and not %t but %s for string. I think I have done a mistake in the last lecture, in the very last example, when we try to figure out what is the problem with the character array that we are trying to print, is that I have used %c there as the format specifier, but that should be %s. I must have forgotten that, sorry for that, so you can correct that. And I think after changing %c with %s, I think you will be able to print the name there without any error. So let's try to run this. First I have to save this, save as C, and it's 18. Okay, let's try to debug it. Okay, now the main thing I'm trying to show here is we have initialized age as 25, we have initialized salary as 25,000, but you can see we have received garbage values here, and only the last one, the last member that we have initialized, got the correct output, has been printed correctly in the output, because union shares, in union all the member shares the same memory space. The first two will be wiped out if the largest one is, or the last one is initialized. So the first two initialized, first I have initialized with 25, but that will be wiped out as soon as I have initialized the second one, and the second one will be wiped out and will hold the garbage value as soon as I have initialized the third one. So the first two will hold now the garbage values or the random values being assigned by the compiler, and only the third one will have the valid value that I have assigned actually. So I think this particular example made clear that what is the basic difference between union and structures, and how you can smartly use unions and structures. It could be a bit tricky, but if you understand the concept of memory management clearly, you can efficiently use union. So I'll try to end this lecture right here. Thank you.